Hello guys. Uh, Today we keep showing the daily questions, and today we got a hard problem: painting grid with three different colors. Okay, is a nice problem for the weekend. So the statement said you're given two integers m and n. Consider an n grid. Okay, so it gives you a grid of the size m and uh, each each cell is initially white. You can paint each cell red, green, or blue. So we have got the three color here. To have three colors, you can paint. Okay, all cells must be painted. So we not leave anything blank. Return a number of ways to color the grid with no two adjacent cells having the same color. Okay, the statement quite clear. So nothing nothing need to be clarified here. So we directly go to the solution. But before that, we take the example. Like for the first example, like the side one, we have two possible this using three color. And for example, 1 2, we got six way. Okay, so the constraint that let's take a look at the constraint here. The m, like the m, the number of rows is only 5, and the number of columns is about thousands. So when we look at the constraints, we can see that the n is medium and the m is small, so we can think about dynamic programming. But you can see that the m is really small, so you can think about dynamic with what we call it bit mass dynamic programming. Uh, that's it, bit mass dynamic programming. So you can search it on Google programming, and you can see some page like this bitmass DP. That's it, the term of the key to show today's problem. It advances technical, so it's really a hard problem. Okay, so what we're gonna do here? That's we need to manage this in Java program. We need to manage the state. So what state we need to manage here? Like let's take zero. Sorry, let's take like 0, because we not leave any cells empty, so we can consider 0 as a red, while 1 as green, 2 is blue. We can use this. We have three color here, so we need to manage that. That's when we construct the row E. We assume that we have construct to the assume that we have constructed to the row E minus 1, and now we need to view the each row. Each column. We assume that we constructed E minus 1 column. So we need to, if we construct this, let's use another color, like this. We need to construct this, and the thing we need to store here is the previous state, like this. For example, like the previous state is like this. So the current, the state of our current column, that's it, must be like for example this. Because the previous column has an effect to the current column. So we need to store the state of the previous column. So So we can use we can use dynamic programming to store like f is and s. That is uh, that is we number subway construct e columns with the state is at. Okay, with the state is like s. Why? So you can we can do we have when we do a dynamic programming problem, we think about the transition formula. That is f is s is what state to this, or let's think about the state, which states can transit to the current state. That is the previous. We check the previous column with the state line as or we can use line t as a minus 1t, which that's t, which t must be what happened with this? What the? Okay, which t has no iterations. Iteration cells with s. What? Okay, with s. That is simply that. So the answer must be the sum of all state. All state t that. This is simply just that. That's it about db bit mass. We store the state of the previous column and contrast on this possible state of the current column to summarize, to sum up it, and we got the answers. So for example, like this, the previous state we have a 1 2 0, so we can have some state like this, 1 0 2, or like 2 2 1 2, or like 2 1 0, no 2 2 0 1, while like 0 with this is 1, and this is sorry, 1 0, this is like we must make sure that we have no adjacent like this, and this the vertical and horizontal. We have it's like as soon as we have a 3 state like here, so the answers must be sum of this. Okay, now we let's start to the okay, let's start to the problem. Previously I have said wrong, like we don't find the current E state that match E minus 1. We find the E minus 1 state that match E state. That is dynamic programming. We find the previous state. Like for example, we want to put the state 1 2 3 0 1 2. So the previous state must be like 1 2 0, or like 2 2 0 1. Like that. Okay. But now we go to the detail. So as the normal DB program, DB dynamic programming, you can use something like a bit mass that is the sequences of 1 0 1 0, like like to represent the state. So as we know that a binary string can be represented as a decimal number, like this is like 5, or this is like 3. Okay, but this problem is have three colors, that means we can use the bit mask, which is binary representation. We must use ternary representation. That's a line, and that is it to a decimal number by the lattice rule is 0 plus 3 2 plus 1 2. So I can 3 slide 2 plus 1 multiple this and this, so it's equal to like 3. The idea here is simply that okay, and from a number like 3 we can convert it to the decimal, the ternary, like for example we use, okay, let's take 5 as an example. So we divide by 3, so we got 1, and this is we have the remainder is 2, so we continue divide it by 3, so we got 0, and the remainder here is 1, so we can represent it as 1 0. Assume that we have 3 digits ternary, so let's try to convert back it to decimal. So we got 3 plus 5. Okay, so the idea of using decimal to represent the ternary number to store the state inside the dynamic inside the DP array for simple calculator. Okay. Okay, right now we're gonna dive into the construct. But first let's calculate the time complexities first. The time, like we have n column, right? We have n column with the state, number of state is like about m. We have 3 power m, because each column have m rows, and with each row we have three way, maximum 3 ways, and like this have 3 way, and this have like 3 way, this have 3 way, so it may be 3 power m, right? It's the maximum state, but we know that some state is not available, enough like this. It can be available because we have 2 iterations is the same, but let's skip that for simple. So this is the total state, but we multiple by the transition state, the number of transitions last is, we need to calculate the previous state, so it's also be 3 power m. But let's take calculate here, like m is 1000, 5 and 5. Okay, it's about lower than 1 second. It's about half a second, so it's maybe past. We know that it's faster because we don't iterate on the state. Yes. So first we need to what we need to do here is to find on the state that's available for each column. Okay, so let's do it. Okay, right. Return in the available states for image states of receive the m, so we can fall from 3 power. So we need to calculate the 3 power first. Like last step. Okay, we let's use total step. It's like 1 and it's like sorry 3, that's the 3 power m. So we iterate from 1 to the total state, because we like this state is 0, and the final state is like 2 let's see about 2 plus 1 minus 1, like it's like 2 minus 3 minus 2 minus 1 to minus like minus 0. Sorry silly thing, this is a silly thing. So we know that from this we just have 3 power 3 total state. It's just the basic math. One can be trained. The problem is the same as we have the 3 column, and how many possible ways to fill this 3 column, which is to have like 1 0 2 and the same. So we have like 3 3, so it's totally 3 power m. Okay. Just a silly calculator combination. So need to convert from an integer to the state, to a state. So we're gonna write some function like turn int a decimal to ternary in h, and we do something like h results return result y result push back is divided by 3 and divided. So we're gonna have the represent decimal to ternary I, and let's check by 4 from 0 to digits minus 1. Proceed if digits g is equal to digits g plus 1. Last, we have 2 adjacent rows in the same column. It had the same color, so we should ignore this. It's okay, but true. It's okay, but false and break. If it's okay, so we post to the available space push back I. So now we have the state. By the way, we need to write a function to check. Let's see, we will see the state 1, and with the state 2, return if true if it's valid. For can assume that. Sorry, we need to use m to put to the prompt like y. Result size let the end result push back 0, 1 and 2. So we use int here might not good, but just a small thing, so we don't need to put too much effort into that. Yes, on string, on the ternary representation must be the length of m. Okay, so let's check for S1. If we know that S1 and S2 have the same length, and 1e is the same as S2i, this must be false, right? Turn true. True is found, it's true, okay. they have two iteration in row. Two iteration is the same column. The same row is the same value, so return false. Okay, now we focus on this, the final step. First we init state, and now we have on the state, so we do dynamic programming. This for to simplify this. I will use the index one and state BP static const mod 99.7 BP. The total state is 3 power 5 is like 3 for 1. We use this. Okay, and the length is 1000. Okay, in the state, so for from what? So for on the state from 0 to okay. So for loop to on the state, for as from available states, oh, available. So I think okay, we okay, so have the type of mistake here, but okay. For the on the available state, and we need to calculate the DPIS. We know that DP00 is like 1. Is the anchor for the state y double states that previous state. Okay, if not available s and t, so we like return okay, so we don't have num, so we use this instead. And to we have 3 state, the side m. We'll use this from 0 to m. If f3 is equal to this, then we can false. So and we iterate to the next bit. We call it bit. Right. If available s and t, we just return. If not available, we return l. We calculate the total weight. That's why on the function add mode here. A plus b if a larger than mode and a minus mode. So now dp is state. Add mode dpi state is the sum of dpi minus 1 previous state. Okay, that's all we got. Here. So the final answer. Okay, final answers. The answers here is 0. The answer is at the last state if you're not equal to n. So add mode answers dpis. The answers, return the answers. It's been a while since the day I showed dynamic programming using bit mask. Decimal to ternary. What? Forgot the end. Forgot the end. Check. Okay, given the end. Return. No, continue. Spam too much. Ooh. Something wrong here. 3 got arrival state, init state, 4 from 1 to total state. Is correct. Okay, it is correct. 102. Sorry, for 102 is for t1 state. First is 0. So all state must be true. So this can be 0. All state of the previous must be a variable. So, okay. If e minus e is equal to 1, so special case, the first column must be on current. What we got I s like 1. Why is this not true? Yes. The most simple way is to initial on the 0 state is correct. It patches. That take some work here. Why is it not correct? Cell must be painted. What happened here? A silly mistake. Okay, it's gonna be correct. Oh yes, it got accepted. Lucky, first hit. Okay, has not it. So the case, if you can what to here and can solve this problem, Let's learn more about dp bit mask. Here the case dp bit mask. Okay.